In this module, we turn your eIDAS 2.0 wallet architecture into something real. You'll design a focused proof of concept, define success metrics, run targeted simulations, and use those results to build a practical, phased roadmap toward production deployment. You've already built a solid foundation: regulations, requirements, target architecture, and detailed protocol flows. We then anchored everything in Azure, wrapped it with security and operations, and compared vendors. Now we'll use that architecture to design a concrete proof of concept and a realistic path to production. A proof of concept is your safety net before committing real time and money. Here, it's about seeing whether the wallet can actually present credentials, be verified, checked against the trust framework, capture user consent, and drive a reliable KYC decision in one smooth flow. That experiment reduces protocol and vendor risk, generates hard evidence for stakeholders, and turns an architecture diagram into something you can see, test, and confidently scale. For a POC, you're proving the wallet-to-relying party flow works end-to-end in a safe, lightweight way. You focus on test wallets, presentation requests, verifying credentials, extracting attributes, recording consent, and making a mock KYC decision. All of this runs with test data in sandbox environments. You deliberately push real onboarding, production customer records, full AML screening, and deep enterprise integrations into later phases. Here's the story this proof of concept needs to tell. A user begins onboarding and the relying party sends an OIDC4VP request for specific attributes. The wallet assembles a verifiable presentation and returns only what was requested. A verifier service checks signatures and trust, extracts the attributes, and logs the user's consent. Finally, a mock KYC engine consumes those trusted attributes to approve, reject, or route the case for review. A good POC environment behaves like a tiny version of your real ecosystem. You expose a sandbox front-end and back-end that trigger onboarding with real OIDC4VP flows. At the center is your verifier, issuing requests, receiving verifiable presentations, and validating them. Around it, you plug in a test wallet, a test credential issuer, and lightweight services for logs, consent, mock KYC outcomes, and configuration, so every integration assumption can be exercised safely. In this step, you validate the full OIDC4VP flow end-to-end. The relying party creates a request with a clear presentation definition, correct nonce, and redirect URI, asking only what onboarding truly needs. The wallet must invoke correctly, show understandable consent, and support selective disclosure where possible. Then you verify the VPP token response, map attributes accurately, and deliberately test failures, expired requests, canceled flows, unsupported credential types, and malformed responses. Once a presentation arrives, the first job is to prove it hasn't been tampered with and really comes from this holder for this audience at this moment. Next, you decide whether you trust the issuer at all, using configured trust lists or registries. Then you check status. Is the credential revoked, suspended, or expired? Only after all checks pass do you extract normalized attributes for downstream KYC decisions. Now the focus shifts from "does it work" to "can we prove trust?" Every onboarding journey should leave a traceable story. When the user consented, for what purpose, which attributes were requested, and which relying party acted. As data flows through wallet presentation, verification, and the mock KYC decision, you log metadata and correlation IDs, not raw credentials. This lets you show GDPR compliance, evidence for AML and KYC, and strong minimization and retention controls. Next, you prove one key idea. Once attributes are verified in a wallet, they can actually run a KYC decision. The POC turns those attributes into a simple onboarding profile, then runs basic rules. Are you old enough in an allowed jurisdiction with enough data to decide? Each outcome, pass, fail, incomplete, or manual review, must integrate cleanly with CRM, case management, and identity systems, while staying traceable back to the original verification events. A proof of concept only teaches you something if you know what good looks like in advance. Here, you define that with a success matrix. For each area, interoperability, protocol behavior, trust and consent, security, audit trail, user experience, and integration. You set clear acceptance criteria, how you'll test, what evidence you'll collect, and who owns it. With that in place, the POC outcome is measurable, defensible, and easy to translate into a go or no-go decision. A credible proof of concept shows that the whole journey works, not just the perfect run. You start with the classic happy path: valid credential, trusted issuer, attributes complete, and the transaction approved. Then you flip it. What happens when users cancel, time out, or abandon? When the tech misbehaves or a trust service is down? And when business rules block onboarding? Each scenario needs a clear expected outcome and evidence you can replay later. Think of the roadmap as de-risking every step before customers ever see the solution. You start with discovery and a POC to validate scope, vendors, and credentials. Then you harden the architecture and clear compliance. Next, you build integrations to onboarding, KYC, and AML, IAM, case management, data stores, and monitoring. Only then do you run security testing, pilot with real users, and roll out production in controlled phases. Production readiness becomes a series of go or no-go decisions, not a single approval. Each gate asks, are the risks understood, owned, and backed by evidence? Architecture owns the design, compliance owns DPIAs and audits, security owns the threat model, operations owns runbooks and support, and vendors own SLAs and performance data. Pilot metrics then validate the real-world impact. Only when all owners meet their criteria do you move to go live. You've now seen how to turn an eIDAS 2.0 wallet KYC concept into a delivery plan. Start with a POC that proves wallet flows, data, consent, and trust. Measure success across UX, security, interoperability, and integration. Then harden, pilot, and roll out in controlled stages. In the next module, you'll assemble the complete capstone architecture pack,